Hello and welcome to the Sleepy Physicist. Tonight, we're embarking on a quiet journey through the cosmos, where humanity's greatest technological achievement in planetary defense discovered something it was never meant to find. This is the story of a system built to save us from catastrophic failure, and the beautiful irony of what it found instead. Now, I do hope this exploration isn't too captivating to keep you awake, but if you find yourself still listening by the time we reach the edge of interstellar space, well, at least you'll have learned something extraordinary about our place in the universe. Before we drift into this cosmic tale, I'd love to know where you're listening from tonight and what time it is in your corner of the world. Whether it's midnight in Melbourne or 3 in the morning in Montreal, you're very welcome here. And if you find these gentle explorations through science and space soothing, consider leaving a like and subscribing to the Sleepy Physicist. It helps more curious minds find their way to these quiet conversations with the cosmos. So settle in, perhaps you're nestled under blankets or curled up somewhere comfortable. Take a deep breath. We're about to explore one of the most fascinating contradictions in modern astronomy, and we have all the time in the universe to do it properly. Picture this. Somewhere in the Chilean desert, a robotic telescope scans the night sky with mechanical precision. Its mission is singular, urgent, and utterly vital to the survival of our species. It searches for death from above, for the kind of cosmic catastrophe that ended the age of dinosaurs and could, without warning, end ours. This is Atlas, the Asteroid Terrestrial-impact last alert system, humanity's final line of defense against extinction-level asteroid impacts. But on a quiet night, in July 2025, Atlas discovered something that defied every expectation, something that revealed the beautiful unpredictability of a universe that refuses to be contained by our purposes, no matter how noble they might be. Instead of finding the destroyer of worlds it was built to detect, Atlas found a visitor from the stars, a wanderer from depths of space so vast that its very existence challenges our understanding of how often such cosmic messengers grace our solar system. This visitor was designated 3I Atlas, the third confirmed interstellar object to pass through our solar system in recorded history. And therein lies our paradox. A system designed to prevent catastrophic failure instead discovered something that represents the exact opposite, a reminder that the universe is full of wonders we never expected to find. To understand the profound irony of this discovery, we need to step back and appreciate what Atlas was truly built for. Imagine, if you will, the ultimate nightmare scenario that keeps planetary scientists awake at night. Not the gentle insomnia of curiosity that might be keeping you awake right now, but the cold terror of knowing that somewhere in the darkness of space there might be a mountain of rock and metal hurtling toward Earth at incomprehensible speeds. The statistics are sobering in their certainty. Every few thousand years, an asteroid large enough to devastate an entire region strikes our planet. Every 100,000 years or so, something large enough to threaten civilization itself makes impact. And every few million years, well, we get events like the one that ended the Cretaceous period 66 million years ago, when a 6-mile-wide asteroid struck what's now Mexico's Yucatan Peninsula and wiped out 3/4 of all life on Earth, including the dinosaurs. The Chicxulub impact, as it's known to science, represents the ultimate catastrophic failure of a planetary system to protect its inhabitants. In an instant, geological speaking, an entire world changed. The impact released energy equivalent to billions of atomic bombs, threw debris into space that rained back down as incandescent meteors. ignited global wildfires, triggered massive tsunamis, and shrouded the planet in darkness for months. It was quite literally the end of the world as it had existed for millions of years. This is the catastrophic failure that Atlas was designed to prevent, not through science fiction heroics or dramatic space missions, but through something far more practical and far more human: early warning. The system's very name tells its story. Atlas provides the last alert, because by the time it detects a dangerous asteroid, there may be only days or weeks to prepare. Not enough time to deflect the object, perhaps, but enough time to evacuate cities, mobilize emergency services, and give humanity a fighting chance to survive what might otherwise be a surprise extinction event. The engineering behind Atlas is elegantly simple in concept, but breathtakingly sophisticated in execution. 4 robotic telescopes, positioned strategically around the globe in Hawaii, Chile, and South Africa, automatically scan the entire visible sky every night. They're looking for something that shouldn't be there, something that moves against the background of stars that have held their positions relative to each other for millennia. When you really think about it, asteroid detection is a peculiar form of cosmic archaeology. These telescopes are essentially time machines, capturing photons that have travelled across the solar system to tell us stories about objects that might have been wandering through space since the formation of the planets themselves. Some of these asteroids are older than life on Earth, ancient remnants from the violent birth of our solar system, still following the gravitational choreography established 4.5 billion years ago. But here's where the story takes its unexpected turn. On July 1st, 2025, the Atlas facility in Chile detected something moving through the constellation of Sagittarius, something that at first appeared to be just another asteroid requiring routine follow-up observations. The object was given a temporary designation and added to the growing catalogue of near-Earth objects that Atlas monitors with such diligent precision. Within hours, however, something remarkable became apparent. This wasn't just another asteroid. Follow-up observations from observatories around the world began to reveal that this object was moving far too quickly to be gravitationally bound to our Sun. Its trajectory was hyperbolic, meaning it was following an open curve through space rather than the closed elliptical orbit that characterizes objects born in our solar system. This was an interstellar visitor, only the 3rd such object ever confirmed to pass through our cosmic neighbourhood, and it had been discovered by a system whose entire purpose was to find objects that pose existential threats to human civilization. The irony is delicious in its completeness. Atlas, searching tirelessly for harbingers of doom, instead found a messenger from the stars. Atlas, as it came to be known, poses no threat to Earth whatsoever. Its trajectory will carry it no closer than about 150 million miles from our planet, roughly the same distance that separates us from the Sun. It's simply passing through, a cosmic tourist on a journey that began in another star system entirely, and will continue long after our Sun has burned out. But what makes this discovery truly extraordinary isn't just the rarity of interstellar objects, though they are indeed fantastically rare. It's what 3i Atlas represents about the fundamental nature of discovery itself. Science, you see, has a wonderful habit of finding things we weren't looking for while we're busy looking for something else entirely. Consider the cosmic context of this moment. 3i Atlas originated somewhere in the vast spaces between the stars, in regions where the temperature hovers just a few degrees above absolute zero, and where the nearest source of light might be trillions of miles away. It has been travelling through this cosmic wilderness for potentially millions of years, a solitary wanderer in the ultimate emptiness, carrying with it the chemical signature of whatever distant stellar system gave it birth. And now, purely by chance, its journey has brought it through our small corner of the galaxy during the brief window of time when human beings have developed the technology to notice its passage. In the entire 14 billion year history of the universe, in all the vast scales of space and time that dwarf human experience, this moment of intersection between our world and this visitor from the stars is so unlikely as to seem almost miraculous. The discovery of 3I Atlas has opened entirely new questions about the frequency of interstellar objects and what they might tell us about the formation and evolution of planetary systems throughout the galaxy. Before 2017, we had never definitively identified an interstellar visitor. Then came ʻOumuamua, that strange elongated object that tumbled through our solar system and departed before we could study it properly. 2 years later, we discovered 2I Borisov, a more conventional-looking comet that allowed astronomers to conduct detailed studies of material formed around another star. Now we have 3I Atlas, and each new discovery is teaching us that the space between star systems isn't as empty as we once imagined. These objects represent a kind of cosmic diaspora, material ejected from young planetary systems during their violent early evolution, now wandering the galaxy as homeless worlds carrying the chemical fingerprints of their lost homes. The James Webb Space Telescope has already begun studying 3I Atlas, revealing that it's unusually rich in carbon dioxide and contains traces of water ice, carbon monoxide, and other compounds. These observations are giving us our first detailed look at material that formed around another star, potentially offering insights into how common Earth-like chemistry might be throughout the galaxy. But perhaps the most profound aspect of this discovery isn't scientific at all. It's philosophical. Here we have a system built from our deepest fears, from our very rational terror of cosmic catastrophe, and instead of confirming our anxieties about the dangers lurking in space, it has shown us something beautiful, that we live in a universe full of wanderers, cosmic nomads carrying stories from distant worlds we may never see. Atlas is moving at about 137,000 miles per hour relative to the Sun, fast enough to cross the entire United States in about 20 minutes. But even at this tremendous speed, its journey from whatever star system gave it birth has likely taken millions of years. It represents patience on a scale that challenges human comprehension, a slow-motion voyage through the cosmic dark that makes our longest space missions seem like brief sprints. As we continue to track 3I Atlas through our telescopes, watching it swing around the Sun and head back into interstellar space, we're witnessing something that connects us to the broader galactic community in ways we're only beginning to understand. This object has seen things we cannot imagine, has travelled through regions of space where our most powerful telescopes show us only emptiness, has carried the chemical legacy of its birth system across distances that light itself takes years to traverse, and it was found by Atlas, our guardian against catastrophic failure, our early warning system against extinction. In searching for death, we found a reminder of life's persistence, of the way matter and energy flow between star systems, carrying information and possibility across the vast spaces that separate one world from another. The discovery raises profound questions about our place in the universe and our relationship with the cosmos that surrounds us. If interstellar objects are more common than we previously thought, what does this mean for the exchange of material between star systems? Could life itself travel between the stars on objects like these, making the galaxy a more connected place than we ever dared to imagine. These questions will occupy astronomers for decades to come, but for now, in this quiet moment of contemplation, we can simply marvel at the beautiful contradiction of it all. A system built to save us from the universe instead showed us how wonderful that universe truly is. The story of 3I Atlas becomes even more remarkable when we consider the technological marvel that made its discovery possible. The Atlas system represents one of humanity's most ambitious attempts to outsmart the universe itself, to peer into the cosmic darkness and identify threats before they become unstoppable. Each Atlas telescope is a study in elegant engineering, equipped with enormous digital cameras that can capture images of sky regions the size of 40 full moons in a single exposure. These cameras contain sensors so sensitive they can detect objects millions of times fainter than what the naked eye can see. Every clear night, they systematically photograph the entire visible sky, creating a continuous movie of the heavens that reveals the subtle dance of objects moving through our solar system. The data processing behind this operation is equally impressive. Each night, Atlas generates terabytes of information, billions of individual measurements of starlight and cosmic radiation. Sophisticated algorithms sift through this data ocean, looking for the telltale signs of moving objects. It's like having a computer program that can spot a single person walking through Times Square by comparing thousands of photographs taken minutes apart. But here's what makes the discovery of 3I Atlas so beautifully ironic. All this technology, all this computational power, all these carefully calibrated instruments scanning the sky with mechanical precision were designed with one primary goal: to find objects that could end human civilization. Instead, they found something that expands our understanding of how rich and interconnected the galaxy truly is. The rarity of what Atlas achieved cannot be overstated. Interstellar objects are incredibly difficult to detect, not just because they're rare, but because they move differently than anything else in our solar system. Most asteroids and comets follow predictable elliptical orbits that bring them repeatedly past the Sun. Their movements can be calculated years or even decades in advance. But interstellar visitors, like 3I Atlas, follow hyperbolic trajectories, open curves that carry them through our solar system exactly once before disappearing forever into the cosmic wilderness. This means that Atlas had only a narrow window of opportunity to spot 3I Atlas. Miss it during its brief passage, and it would have vanished undetected, carrying its secrets back into the interstellar void. The fact that we caught it at all represents a kind of cosmic lottery win, a moment when human technology and cosmic timing aligned in perfect synchronization. As 3I Atlas continues its journey through our solar system, astronomers are racing to learn everything they can about this visitor from the stars. The Hubble Space Telescope has measured its size, revealing a nucleus likely less than a kilometre across, smaller than most mountains but carrying within it the chemical fingerprints of an entirely different stellar neighbourhood. Ground-based observatories have detected gases streaming from its surface as it warms in the sun's light, creating the characteristic tail that marks it as a comet rather than an asteroid. This tail contains cyanide and nickel vapour, compounds that tell us about the conditions in the outer regions of whatever planetary system gave birth to 3I Atlas billions of years ago. Each spectroscopic measurement, each photograph, each data point collected about this object represents a message from another world. We're essentially doing archaeology on a visitor from the stars, piecing together clues about environments and processes that occurred around a sun we may never identify, in a region of space we may never visit. The Very Large Telescope in Chile has revealed that 3I Atlas contains organic compounds, complex carbon-based molecules that could potentially serve as the building blocks for life. This discovery raises profound questions about the distribution of life-supporting chemistry throughout the galaxy. If objects like 3I Atlas regularly carry organic materials between star systems, could they be part of a vast galactic ecosystem, spreading the ingredients for life from one world to another? Consider the implications of this possibility. Every interstellar object might be a kind of cosmic seed pod, carrying not just the chemical signatures of its birth system, but potentially the molecular precursors that could contribute to the emergence of life on worlds it encounters during its journey. The galaxy might be far more biologically connected than we ever imagined, with wandering objects like 3I Atlas serving as messengers between distant worlds. This perspective transforms our understanding of planetary systems from isolated islands in space to nodes in a vast network of chemical and potentially biological exchange. The comets and asteroids we see in our own solar system might carry within them the molecular legacy of countless other worlds, accumulated during billions of years of cosmic wandering. But let's return to our central irony. Atlas was built to protect us from what scientists call planet killers, asteroids large enough to cause global devastation. The system can detect objects as small as 20 meters across when they're still days away from Earth. That might not sound like much advance warning, but it's enough time to evacuate cities, redirect air traffic, and mobilize emergency response teams. For larger objects, those capable of regional or global devastation, Atlas can provide weeks or even months of advance notice. This early warning capability represents a fundamental shift in humanity's relationship with cosmic threats. For the first time in our species' history, we don't have to face the possibility of asteroid impact as helpless victims. We can see it coming. The psychological impact of this capability cannot be understated. Throughout human history, natural disasters have been events that simply happen to us. Earthquakes, volcanoes, hurricanes, tsunamis, all represent forces of nature that we can prepare for but cannot prevent. Asteroid impacts were the ultimate expression of this powerlessness. Cosmic catastrophes that could arrive without warning and reshape civilization in an instant. Atlas changes this equation. It transforms asteroid impacts from unpredictable acts of cosmic violence into manageable risks that can be anticipated, planned for, and potentially prevented. The system represents a kind of technological evolution of the human survival instinct, extending our awareness beyond the immediate environment to encompass threats from the depths of space. Yet in building this protective shield, in creating this early warning system against cosmic catastrophe, we've also created something unexpected, a discovery engine for the rare and wonderful. Atlas doesn't just find dangerous asteroids, it reveals the hidden population of objects that share our solar system. The quiet wanderers that pose no threat but carry stories worth telling. The discovery of 3I Atlas reminds us that the universe is under no obligation to conform to our expectations or fulfill our purposes. We built a system to find destroyers and instead found a messenger. We reached out into space with instruments of fear and grasped something that inspires wonder. This pattern repeats throughout the history of astronomy. Galileo pointed his telescope at Jupiter to study the planets and discovered moons, revealing that Earth was not the centre of all celestial motion. Edwin Hubble used the world's largest telescope to measure the distances to nearby galaxies and instead discovered that the entire universe is expanding. The Cosmic Background Explorer satellite was built to study the afterglow of the Big Bang and ended up revealing the quantum fluctuations that eventually grew into all the galaxies we see today. Atlas fits perfectly into this tradition of unexpected discovery. It represents the universe's gentle reminder that reality is far stranger, far more wonderful, and far more interconnected than our limited human perspective might suggest. We live in a cosmos where wandering mountains of ice and rock carry chemical messages between the stars, where the space between solar systems is populated by nomadic worlds, following trajectories that span millions of years. The object's trajectory tells a story of unimaginable patience. Atlas has been travelling through interstellar space for possibly millions of years, moving through regions where the temperature hovers just above absolute zero, and where the nearest source of light might be dozens of light years away. It has crossed distances so vast that even light, the fastest thing in the universe, takes years to traverse them. During this cosmic odyssey, 3i Atlas has been slowly changing. Cosmic rays, high-energy particles that stream through interstellar space, have been gradually altering its surface chemistry. Collisions with interstellar dust grains, particles smaller than smoke but moving at tremendous speeds, have been slowly eroding its outer layers. The object we see today is not exactly the same as the one that left its birth system eons ago, yet despite these changes, despite the countless years of cosmic weathering, 3i Atlas still carries within it the chemical fingerprints of its origin. The carbon dioxide, water ice, and organic compounds detected by our telescopes are messages from another world, preserved in the deep freeze of interstellar space, and now delivered to our solar system like a letter that has taken millions of years to arrive. The timing of this delivery is itself remarkable. Atlas is visiting our solar system during the brief window of cosmic history when human beings exist and have developed the technology to recognize its significance. In the 14 billion year history of the universe, in all the vast scales of space and time, this moment of intersection between our civilization and this visitor from the stars represents a coincidence so unlikely it seems almost magical. Consider the chain of circumstances that had to align for this discovery to occur. Atlas had to be ejected from its birth system billions of years ago, probably during the violent early evolution of a young planetary system. It had to survive the journey through interstellar space, avoiding collisions with other objects and maintaining enough structural integrity to remain detectable. Its trajectory had to carry it through our solar system during the brief span of time when humans exist and have built instruments capable of spotting its passage. Meanwhile, on Earth, our species had to evolve, develop technology, survive countless existential threats, and eventually build a network of robotic telescopes dedicated to scanning the sky for dangerous objects. The Atlas system had to be operational, the weather had to be clear, and the object had to pass through a region of sky where it could be distinguished from the background stars. Each of these requirements represents a probability so small as to be almost negligible. The fact that they all came together at this moment in cosmic history transforms the discovery of 3i Atlas from a simple astronomical observation into something approaching a miracle of timing and circumstance. This perspective reveals something profound about the nature of discovery itself. Every scientific breakthrough, every moment of insight, every expansion of human knowledge represents a convergence of countless factors that could easily never have aligned. The universe is under no obligation to reveal its secrets to us, yet somehow, through a combination of curiosity, persistence, and extraordinary good fortune, we continue to uncover truths that transform our understanding of reality. The story of 3i Atlas also illustrates the beautiful unpredictability of scientific research. The astronomers who designed and built the Atlas system could never have anticipated that their asteroid hunting telescope would become humanity's first systematic detector of interstellar visitors. They built an instrument with one purpose and discovered that it could serve another entirely unexpected function. This kind of serendipity is woven into the fabric of scientific discovery. The tools we build to answer one question inevitably reveal new questions we never thought to ask. The instruments we design for one purpose often find their greatest significance in applications we never imagined. As we continue to study 3i Atlas during its brief visit to our solar system, we're not just learning about this particular object. We're developing techniques and insights that will help us understand future interstellar visitors, building a framework for interpreting the chemical messages they carry from distant worlds. Each new interstellar object we discover adds another piece to our understanding of how matter flows through the galaxy, how planetary systems exchange material across the vast spaces that separate them. We're beginning to see that the galaxy itself might be a kind of ecosystem, with wandering objects like 3i Atlas serving as vectors for chemical and potentially biological exchange between distant worlds. This emerging picture of galactic connectivity challenges our traditional view of planetary systems as isolated islands in space. Instead, we're discovering that we live in a universe where the building blocks of worlds, and possibly life itself, flow between the stars on cosmic currents. We're only beginning to understand. The implications extend far beyond astronomy. If interstellar objects regularly carry organic compounds between star systems, the emergence of life might be a more connected, galactic scale phenomenon than we ever imagined. The chemistry that gave rise to life on Earth might have cosmic roots, delivered by wandering objects that carried the molecular seeds of biology across the interstellar void. These are the kinds of profound questions that emerge when we find things we weren't looking for, when our instruments of fear discover messengers of wonder, when our preparations for catastrophe reveal the hidden connectivity of the cosmos. The discovery of 3i Atlas represents something even more extraordinary when we consider the vast loneliness it has endured. This object has spent potentially millions of years travelling through what we call the local bubble, a region of space carved out by ancient stellar explosions, where the density of matter is so low that you could travel for light years without encountering anything larger than a grain of dust. Imagine the profound solitude of such a journey. While Earth teemed with life, while continents drifted and mountains rose and fell, while entire species evolved and went extinct, 3i Atlas drifted through the cosmic dark in perfect silence. No atmosphere to carry sound, no weather to break the monotony, just a steady, patient pull of distant gravity wells guiding its trajectory through the galaxy's spiral arms. And yet, this isn't a story of isolation. It's a story of connection across impossible distances. Because 3i Atlas carries within its frozen heart the molecular memory of another world, another time, another stellar neighbourhood, where the laws of physics played out in subtly different ways. The water ice locked in its nucleus might have condensed from vapor clouds, warmed by a star whose light has never reached Earth. The organic compounds detected in its tail might have formed in chemical reactions powered by cosmic rays in interstellar space, creating complexity from simplicity across eons of time. This transforms our understanding of chemistry itself. We tend to think of chemical processes as requiring the warm, nurturing environments of planetary surfaces, the liquid water and moderate temperatures that allow molecules to dance together in the intricate choreography that produces life. But 3i Atlas suggests that the universe is far more creative than we imagined, that complex chemistry can unfold in the apparent emptiness between the stars, driven by energies and processes we're only beginning to understand. The James Webb Space Telescope's observations have revealed that 3i Atlas contains not just simple compounds like water and carbon dioxide, but complex organic molecules that could potentially serve as building blocks for biological processes. These aren't just random chemical accidents. They represent sophisticated molecular architecture that emerged somewhere in the cosmic wilderness, shaped by forces and conditions that exist nowhere on Earth. Consider what this means for our search for life beyond our solar system. We've been looking for habitable worlds, planets with liquid water and stable atmospheres where biology might take hold and flourish. But what if life's origins are more distributed than we imagined? What if the galaxy itself serves as a kind of vast chemical laboratory, with wandering objects like 3i Atlas carrying the products of cosmic experimentation from one star system to another? This perspective suggests that the emergence of life might not be a rare accident confined to isolated worlds, but part of a galactic-scale process of chemical evolution that connects distant regions of space through the patient migration of molecular messengers. Every interstellar object becomes a potential library, carrying information about chemical processes that occurred in environments we may never directly observe. The philosophical implications are staggering. If this view is correct, then we're not isolated on a lonely planet orbiting an ordinary star in an unremarkable part of the galaxy. We're participants in a cosmic conversation that has been ongoing for billions of years, recipients of chemical wisdom that has travelled impossible distances to reach us. But let's return to the beautiful irony that brought us here. Atlas was built with a very specific fear in mind: the terror of sudden extinction from space. The system embodies our species' hard-won wisdom about the dangers lurking in the cosmic dark, our recognition that the universe contains forces powerful enough to end civilization without warning or mercy. This fear is not irrational. It's based on solid evidence written in the geological record of our planet. The Chicxulub impact that ended the age of dinosaurs was not a unique event, merely the most recent example of cosmic violence that has repeatedly reshaped the story of life on Earth. Before that, there was the Permian extinction, the late Devonian extinction, a long catalogue of catastrophes that have punctuated the otherwise steady evolution of our biosphere. Each of these events represents a failure of the planetary defence systems that existed at the time, though of course no such systems existed beyond the natural barriers provided by our atmosphere and the gravitational influence of Jupiter, which sweeps up many dangerous objects before they can reach the inner solar system. For most of Earth's history, life has been at the mercy of cosmic accident, surviving not through planning or preparation, but through the blind luck of statistical probability. Atlas changes this ancient vulnerability. For the first time in the 4.5 billion year history of our planet, we have the capability to see extinction coming, not just to suffer through it or adapt to its aftermath, but to anticipate it, prepare for it, and potentially prevent it altogether. The technology behind this capability represents one of humanity's most impressive achievements in what we might call defensive astronomy. Each Atlas telescope operates with a precision that would have seemed impossible just decades ago, tracking objects across the sky with accuracy measured in fractions of an arc-second, detecting motion so subtle that it would be invisible to the most careful human observer. The mathematics involved are equally impressive. Predicting the future trajectory of an asteroid requires solving what's known as the N-body problem, calculating the gravitational influences of the Sun, planets, and moons on an object that might be millions of miles away and moving at tens of thousands of miles per hour. These calculations must account for subtle effects, like the pressure of sunlight itself, which can gradually alter an object's orbit over long periods of time. Yet despite this mathematical sophistication, despite the engineering precision of the telescopes and the computational power of the data processing systems, Atlas operates on a fundamentally simple principle. It looks for things that move against the background of stars that appear stationary on human timescales. It's cosmic motion detection on an industrial scale, automated vigilance that never tires, never gets distracted, never fails to notice when something new appears in the sky. And on that quiet July night in 2025, this system of mechanical watchfulness detected something that redefined our understanding of how often the universe sends us visitors from beyond our solar system. The discovery of 3I Atlas suggests that interstellar objects might be far more common than we previously imagined, perhaps passing through our cosmic neighborhood every few years rather than every few decades. This has profound implications for our understanding of galactic dynamics. If interstellar objects are relatively common, then the exchange of material between star systems might be an ongoing process, a kind of slow-motion circulation that has been connecting distant regions of the galaxy for billions of years. Picture the Milky Way not as a collection of isolated stellar systems, but as a vast ecosystem where matter flows between worlds on currents measured in millions of years. Planets eject material during their violent formation phases. This material wanders through interstellar space, occasionally being captured by other stellar systems or simply passing through them like cosmic tumbleweeds. Over time, the chemical signature of one star system becomes distributed throughout the galaxy, creating a kind of molecular diaspora that connects distant worlds. This process might help explain some of the puzzling uniformities we observe in the galaxy's chemical composition. Stars in different regions of the Milky Way show remarkably similar abundances of heavy elements, despite being separated by thousands of light years and having formed at different times. Perhaps this uniformity reflects not just the mixing that occurred during the galaxy's formation, but ongoing exchange of material through the migration of interstellar objects. The discovery of 3I Atlas also raises intriguing questions about the frequency of such objects and what this might mean for the future of astronomy. If interstellar visitors are more common than we thought, then systems like Atlas might regularly discover objects that challenge our understanding of planetary system evolution and the processes that eject material into interstellar space. Each new interstellar object becomes a time capsule carrying information about conditions that existed in other stellar systems billions of years ago. By studying these visitors, we can essentially do archaeology on distant worlds, piecing together stories about planetary formation processes that occurred in regions of the galaxy we may never visit. The chemical analysis of 3I Atlas has already revealed surprises that are reshaping our theories about how comets form and evolve. The object's unusual composition suggests that it formed in a region of its birth system where conditions were quite different from those that existed in the outer reaches of our own solar system when our planets were forming. This gives us a glimpse into the diversity of planetary formation processes that might occur around other stars. But perhaps the most remarkable aspect of this discovery is how it illustrates the interconnected nature of modern astronomy. The detection of 3I Atlas required not just the Atlas telescopes in Chile, but follow-up observations from facilities around the world. Amateur astronomers contributed observations that helped refine the object's orbit. Space telescopes provided detailed spectroscopic analysis. Ground-based observatories tracked its motion and brightness changes. This global collaboration represents something new in the history of astronomy, a kind of planetary nervous system that can respond rapidly to unexpected discoveries. When 3I Atlas was first detected, astronomers around the world received automated alerts within hours. Telescopes were redirected to observe the object, data was shared in real time, and within days the astronomical community had confirmed that this was indeed an interstellar visitor. The speed and efficiency of this response reflects decades of preparation for exactly this kind of discovery. The systems and protocols that made it possible were developed not for finding interstellar objects, which were thought to be extremely rare, but for tracking potentially dangerous asteroids and comets. Once again, we see how tools built for one purpose can reveal wonders we never expected to find. This pattern of unexpected discovery runs like a golden thread through the history of science. We build instruments to answer specific questions and inevitably find that they open doors to questions we never thought to ask. We create technologies to solve practical problems and discover that they reveal hidden layers of reality we never knew existed. The Atlas system embodies this beautifully. Built to protect us from cosmic catastrophe, it has instead become a window into the hidden population of objects that wander between the stars. Designed to find destroyers, it has discovered messengers. Created from fear, it has generated wonder. As 3I Atlas continues its journey through our solar system, gradually accelerating as it approaches the Sun before beginning its long voyage back into interstellar space, we're witnessing something that connects us to the deepest mysteries of cosmic evolution. This object represents a bridge between worlds, a physical link between our solar system and stellar neighborhoods that may be hundreds of light years away. The trajectory calculations show that 3I Atlas will reach its closest approach to the Sun in early 2026, when it will be moving at nearly 200,000 miles per hour relative to our star. At that point, it will be receiving roughly 4 times as much solar energy as Earth does, enough to drive significant outgassing from its surface and create the spectacular tail that marks it as an active comet. This warming process will provide our best opportunity to study the object's composition in detail. As ice sublimates from its surface and carries dust and other materials into space, spectroscopic analysis will reveal the chemical fingerprints that tell us about conditions in its birth system. We'll be reading a message written in molecules, deciphering the story of a world we may never see through the chemistry of a wandering ambassador that has travelled millions of years to reach us. The observations planned for this close approach represent some of the most sophisticated remote sensing ever attempted on an interstellar object. Multiple space telescopes will coordinate their observations to capture data across the electromagnetic spectrum, from radio waves to gamma rays. Ground-based observatories will track the object's motion and brightness changes with unprecedented precision. These observations will do more than just tell us about 3R Atlas itself. They will help us develop the techniques and technologies needed to study future interstellar visitors, building a framework for understanding the chemical diversity of objects that originate in other stellar systems. Each new interstellar object we discover adds another piece to our understanding of how matter flows through the galaxy and how planetary systems evolve over cosmic time. The discovery also highlights the importance of continued investment in astronomical survey systems like ATLAS. These facilities represent our early warning system not just against cosmic catastrophe, but against missing opportunities to learn about the universe around us. Every clear night that passes without systematic sky monitoring is a night when we might miss a visitor from the stars, a chemical messenger carrying information that could transform our understanding of how the galaxy works. The cost of maintaining these systems is modest compared to their potential impact on human knowledge. The entire ATLAS network operates on an annual budget that's less than what many countries spend on a single military aircraft. Yet it provides capabilities that are literally irreplaceable. Once an interstellar object passes through our solar system and disappears back into the cosmic wilderness, the opportunity to study it is gone forever. This economic perspective reveals something profound about the priorities that shape our exploration of the universe. We invest enormous resources in technologies designed to protect us from human-made threats, yet the systems that guard against cosmic dangers and enable cosmic discovery operate on comparatively tiny budgets. The ATLAS telescopes that discovered 3R Atlas represent humanity's most advanced defense against extinction-level asteroid impacts. Yet their combined cost is less than a single major infrastructure project. Perhaps this reflects our species' tendency to focus on immediate, tangible threats while underestimating the importance of longer-term, more abstract dangers and opportunities. Asteroid impacts and interstellar visitors operate on timescales that dwarf human attention spans, making them easy to ignore until they suddenly demand our attention. Yet the discovery of 3I Atlas reminds us that the universe operates on these vast timescales, whether we pay attention or not. Cosmic processes unfold over millions and billions of years, creating patterns and connections that become visible only when we develop the patience and technology to observe them systematically. The story of this discovery also illustrates how scientific understanding evolves through the accumulation of unexpected observations. Before 2017, textbooks described interstellar objects as theoretical possibilities, predicted by models of planetary system formation, but never actually observed. The discovery of ʻOumuamua changed that, proving that such objects exist and pass through our solar system occasionally. The subsequent discovery of 2R Borisov confirmed that ʻOumuamua wasn't a unique event, while providing our first detailed look at an interstellar comet. Now 3I Atlas suggests that these objects might be relatively common, potentially passing through our cosmic neighbourhood every few years rather than every few decades. This rapid evolution in our understanding reflects the power of systematic observation combined with advanced technology. The same instruments that can detect potentially dangerous asteroids millions of miles away are sensitive enough to spot the subtle signatures of interstellar visitors, objects so rare that encountering them was once considered a once-in-a-lifetime astronomical event. The implications extend far beyond astronomy into fundamental questions about the nature of scientific discovery itself. How often do we miss important phenomena simply because we're not looking for them in the right way or at the right time? How many secrets does the universe hold that could be revealed if we just had the patience and resources to observe systematically? The discovery of 3I Atlas suggests that the answer might be more than we ever imagined. The cosmos is full of messengers carrying information about processes and environments we've never directly observed. Some of these messengers, like 3I Atlas, come to us from the depths of interstellar space. Others might be hiding in plain sight, waiting for the right instruments and the right questions to reveal their significance. This perspective transforms our relationship with the unknown from passive acceptance to active engagement. Instead of simply acknowledging that there are things we don't understand about the universe, we can build systems that systematically search for the unexpected, that remain alert for the kinds of surprises that reshape our understanding of reality. The Atlas telescopes embody this approach perfectly. They were built to solve a specific problem, but their designers were wise enough to make them flexible enough to contribute to discoveries they never anticipated. This kind of adaptable technology represents one of our species' most powerful tools for expanding the boundaries of knowledge. As we continue to study 3I Atlas and prepare for future interstellar visitors, we're not just learning about individual objects. We're developing a new branch of astronomy, a systematic approach to understanding how matter and information flow between stellar systems across the vast spaces that separate them. This emerging field might ultimately prove as significant as any other branch of astronomical research. If interstellar objects regularly carry organic compounds and other complex molecules between star systems, they might play a crucial role in the distribution of the chemical building blocks necessary for life. Understanding this process could transform our approach to searching for life beyond Earth, and our understanding of how biology emerges and spreads throughout the galaxy. The philosophical implications are equally profound. The discovery of 3I Atlas reminds us that we live in a universe where connections exist across impossible distances, where objects carry messages between worlds separated by millions of years of travel time, where the apparent emptiness of space is actually filled with wandering messengers carrying stories we're only beginning to learn how to read. These cosmic messengers connect us to the broader galactic community in ways we're still trying to understand. They remind us that our solar system is not an isolated island in space, but part of a vast network of matter and energy exchange that has been operating for billions of years. We are recipients of chemical wisdom that has travelled from distant worlds, participants in conversations that began long before our species existed and will continue long after we're gone. This perspective offers a kind of cosmic comfort, a reminder that we're part of something much larger and more enduring than our individual lives or even our civilization. The same physical processes that gave rise to life on Earth are operating throughout the galaxy, creating complexity and beauty on scales we can barely comprehend. The discovery of 3I Atlas by the Atlas system represents a perfect example of this cosmic connectivity. A network of telescopes built to protect us from destruction instead revealed a messenger from the stars, transforming our understanding of how interconnected the galaxy really is. Fear became wonder, defense became discovery, and our preparations for catastrophe unveiled the hidden beauty of cosmic wandering. As this remarkable visitor continues its journey through our solar system, carrying with it the chemical memories of a distant world, we're reminded that the universe is far stranger, far more wonderful and far more connected than our earthbound perspective might suggest. We live in a cosmos where mountains of ice and rock carry messages between the stars, where the space between worlds is populated by nomadic ambassadors following trajectories that span geological ages. The story of 3I Atlas is still being written. As it approaches the Sun and begins its long journey back into interstellar space, it will carry with it not just the chemical signatures of its ancient birth, but also the subtle influence of its passage through our solar system. Solar radiation will have altered its surface chemistry slightly. Gravitational interactions with our planets will have nudged its trajectory by infinitesimal amounts. In this way, 3I Atlas becomes not just a messenger bringing us information from distant worlds, but also a messenger carrying information about our world to whatever cosmic destinations await it in the galactic future. It's a two-way exchange, a conversation between worlds conducted through the patient migration of matter across the vast spaces that separate the stars. This perspective raises one of the most profound questions in modern astronomy. What does the frequency of interstellar visitors tell us about the architecture of the galaxy itself? If objects like 3I Atlas are more common than we previously imagined, then we're living in a universe where the boundaries between stellar systems are far more porous than we ever dared to hope. Think about it for a moment. Every interstellar object represents a physical bridge between worlds that may be separated by hundreds or thousands of light years. These cosmic wanderers carry within their frozen hearts the actual substance of other worlds, the literal atoms and molecules that condensed from stellar nebula around distant suns. When we study 3I Atlas, we're not just observing it from afar, we're analysing matter that formed in an entirely different stellar neighbourhood, possibly under conditions that exist nowhere in our solar system. The implications ripple outward, like waves in a cosmic pond. If interstellar objects are relatively common, if they've been crossing the galaxy for billions of years, then the chemical evolution of stellar systems might be far more interconnected than we ever imagined. The heavy elements that make up planets like Earth, the carbon and oxygen and nitrogen that form the backbone of biological molecules, might not be confined to their stellar birthplaces, but distributed throughout the galaxy by these patient wanderers. This transforms our understanding of galactic chemistry from a collection of isolated laboratories to a vast, interconnected system of material exchange. Over cosmic time, the products of stellar nucleosynthesis, the complex molecules forged in the hearts of dying stars, don't just remain locked in their original stellar systems. They travel, they migrate, they cross impossible distances to seed new worlds with the chemical diversity necessary for complexity to emerge. Consider what this means for the emergence of life itself. We've long wondered whether the conditions that gave rise to biology on Earth are common or rare in the universe. But what if we're asking the wrong question? What if life's emergence depends not just on the conditions in individual stellar systems, but on the slow accumulation of chemical complexity delivered by interstellar messengers over billions of years? The organic compounds detected in 3I Atlas might represent the products of chemical evolution that occurred not around a single star, but during millions of years of wandering through the interstellar medium. Cosmic rays, those high-energy particles that stream through space, can drive chemical reactions in the frozen surfaces of interstellar objects, creating molecular complexity in environments where no planets exist. This opens up entirely new possibilities for where and how the building blocks of life might form. Instead of requiring the warm, nurturing environments of planetary surfaces, complex chemistry might unfold in the apparent emptiness between the stars, driven by processes we're only beginning to understand. The galaxy itself becomes a kind of vast chemical laboratory, with wandering objects like 3I Atlas serving as both reaction vessels and delivery systems. But let's pause here and return to the beautiful irony that started our journey. Atlas was built from humanity's most rational fear, our recognition that the cosmos contains forces capable of ending civilization without warning. The system represents our species' hard-won wisdom about the dangers that lurk in the darkness between worlds. Our technological response to the kind of catastrophic failure that ended the age of dinosaurs. Yet in building this shield against cosmic violence, we've created something that reveals the universe's gentler face. The same instruments that scan the sky for harbingers of doom have shown us that space is populated by messengers carrying chemical wisdom from distant worlds. Our preparations for destruction have unveiled networks of cosmic connection that span the galaxy. There's something deeply moving about this reversal of expectation. It suggests that the universe, despite its capacity for violence and chaos, operates according to principles that favour connection over isolation, communication over silence. The space between the stars isn't empty. It's filled with wandering libraries, cosmic archives, carrying the molecular memories of worlds we may never see. The discovery of 3I Atlas also illuminates something profound about the nature of time in the universe. This object has been travelling for potentially millions of years, crossing distances so vast that light itself takes decades or centuries to traverse them. During its journey, entire civilizations could have risen and fallen on distant worlds, stars could have been born and died, planets could have formed, evolved complex biospheres, and been sterilized by cosmic catastrophe. Yet 3I Atlas has persevered, maintaining its structural integrity across eons of cosmic weathering. It has survived bombardment by cosmic rays, collisions with interstellar dust, and the gradual erosion of its surface by the thin but persistent flow of particles that fills the space between stars. It represents a kind of geological patience that challenges human comprehension. This patience extends to our own observations. The light we're using to study 3I Atlas left its surface hours or days ago, depending on its distance from Earth. The chemical signatures we detect in its spectrum reflect processes that might have occurred millions of years ago, when the object was formed in the outer reaches of an alien planetary system. We're doing archaeology on a cosmic scale, reading ancient history written in the language of atoms and molecules. The temporal complexity becomes even more intricate when we consider that 3I Atlas is simultaneously ancient and contemporary. The water ice in its nucleus might have condensed from vapor clouds that formed shortly after its birth system's planets finished accreting. The organic compounds in its coma might have been created by chemical reactions driven by cosmic rays during its millions of years of interstellar wandering. The gases we observe streaming from its surface are being created right now, as solar radiation sublimates ice and drives chemistry that hasn't occurred since the object left the cold darkness of interstellar space. We're witnessing the reawakening of a world that has slept for millions of years, watching as solar warmth brings ancient chemistry back to life. The tale of 3I Atlas isn't just a beautiful astronomical phenomenon. It's a resurrection, a revival of chemical processes that have been dormant since this object last encountered the energy of a star. This reawakening process reveals something fundamental about the nature of information in the universe. The chemical signatures locked in 3I Atlas represent a form of cosmic memory, information about conditions and processes that existed in another star system billions of years ago. This information has been preserved in the deep freeze of interstellar space, maintained across impossible distances and unimaginable spans of time. Now, as solar radiation warms the object's surface, this ancient information is being released into space, where our instruments can capture and decode it. We're reading a message that was written before our solar system finished forming, delivered by a messenger that has travelled farther than human imagination can easily grasp. The philosophical implications are staggering. If objects like 3I Atlas regularly carry information between star systems, then the galaxy might possess a kind of distributed memory, a vast network of chemical archives that preserve the history of cosmic evolution across billions of years. Every interstellar object becomes a potential time capsule, carrying forward the molecular legacy of worlds and processes that might otherwise be lost to the passage of time. This transforms our understanding of cosmic evolution from a purely local phenomenon to a galactic-scale process of information exchange and preservation. The history of the universe isn't just written in the light from distant galaxies or the background radiation left over from the Big Bang. It's also encoded in the wandering objects that cross the spaces between stars, carrying with them the chemical memories of countless worlds. But perhaps the most remarkable aspect of this cosmic information network is its accessibility. Unlike the distant galaxies whose light takes billions of years to reach us, interstellar objects like 3I Atlas bring their information directly to our doorstep. They allow us to study material from other star systems with the same instruments we use to analyze samples from our own planets and moons. This represents a fundamental shift in our ability to understand the galaxy around us. Instead of relying solely on remote observation of distant objects, we can now conduct detailed chemical analysis of material that formed around other stars. It's as if the galaxy has developed its own postal system, delivering samples from distant worlds directly to our laboratories. The Atlas discovery of 3I Atlas demonstrates how this cosmic postal system operates. The object was first detected as a moving point of light against the background stars, no different in appearance from the thousands of asteroids that Atlas catalogues every year. Only through careful observation and mathematical analysis did astronomers realize they were looking at something extraordinary, a visitor from the depths of interstellar space. This highlights the importance of systematic observation in astronomy. Most of the universe's secrets don't announce themselves with dramatic fanfare. They reveal themselves gradually through the patient accumulation of precise measurements and careful analysis. The discovery of 3I Atlas required not just sophisticated instruments, but also the persistence to observe the sky night after night, year after year, building up the baseline of knowledge necessary to recognize when something truly unusual appears. This kind of systematic vigilance represents one of humanity's most powerful tools for expanding our understanding of the cosmos. By maintaining continuous observation of the sky, by cataloguing and tracking the movements of countless objects, we create the foundation for recognizing the exceptional when it appears among the ordinary. The Atlas system embodies this approach perfectly. Its 4 telescopes operate with mechanical precision, scanning the entire visible sky every clear night, creating an ever-growing database of celestial motion. Most of the objects they detect are routine, familiar members of our solar system following predictable orbits. But occasionally, very rarely, something appears that doesn't fit the pattern. When that happens, the system's true power becomes apparent. Within hours of detecting an unusual object, Atlas can alert astronomers around the world, triggering a coordinated response that brings together the most advanced astronomical instruments on and above our planet. This rapid response capability transforms fleeting opportunities into detailed scientific investigations. The discovery of 3I Atlas demonstrates this process at its finest. From initial detection to confirmed interstellar origin took only days. A remarkable achievement, considering that similar discoveries in the past might have taken weeks or months to verify. This speed of confirmation allows astronomers to begin detailed studies while the object is still visible and accessible to observation. But the true significance of this discovery extends far beyond the technical achievement of rapid identification and characterization. 3I Atlas represents a fundamental expansion of our cosmic perspective, a reminder that we live in a universe where connections exist across impossible distances and information flows between worlds on timescales that dwarf human experience. Every time we observe this visitor from the stars, we're participating in a conversation that began millions of years ago in another stellar system and will continue long after 3I Atlas disappears back into the interstellar wilderness. We're reading messages written in the language of chemistry, deciphering stories told through the arrangement of atoms and molecules that formed under alien suns. This perspective transforms astronomy from a purely observational science into something approaching archaeology or anthropology. We're not just measuring the properties of distant objects, we're interpreting the remnants of processes and environments that existed in other times and places, piecing together the history of cosmic evolution from the fragments that chance has delivered to our doorstep. The chemical analysis of 3I Atlas has already revealed surprises that are reshaping our understanding of how comets form and evolve. The object's unusual composition suggests formation conditions quite different from those that existed in the outer reaches of our own solar system. This gives us our first direct evidence for the diversity of planetary formation processes that might occur around other stars. But perhaps more significantly, the organic compounds detected in 3I Atlas raise profound questions about the distribution of complex chemistry throughout the galaxy. These molecules represent sophisticated chemical architecture that emerge somewhere in the cosmic wilderness, far from the warm, nurturing environments we typically associate with complex chemistry. This discovery suggests that the universe is far more creative than we previously imagined, that chemical complexity can emerge in environments we've barely begun to explore or understand. The apparent emptiness between the stars might actually be filled with chemical laboratories where cosmic rays and other high-energy processes drive reactions that create molecular complexity from simple starting materials. If this is true, then the building blocks of life might be distributed throughout the galaxy by processes that operate on scales and timescales far grander than anything we've previously considered. Life's emergence might not depend solely on the conditions that exist on individual planets, but on the slow accumulation of chemical complexity delivered by interstellar messengers over billions of years. This perspective offers a kind of cosmic optimism, suggesting that the universe actively works to distribute the materials necessary for complexity and possibly life itself. Instead of viewing the space between stars as a barrier that isolates worlds from each other, we can see it as a medium that connects them, a vast ocean across which chemical wisdom flows from one stellar system to another. The implications for our search for life beyond Earth are profound. Instead of looking only at individual planets, and asking whether they have the right conditions for biology to emerge locally, we might also need to consider the possibility that life's building blocks are delivered from elsewhere, carried by wandering objects that have accumulated chemical complexity during millions of years of interstellar travel. This doesn't diminish the importance of planetary conditions for life's emergence and evolution. Liquid water, stable atmospheres, and energy sources remain crucial for biological processes as we understand them, but it suggests that the chemical foundation for life might be laid by processes that operate on galactic scales, creating a kind of cosmic ecosystem where distant worlds contribute to each other's potential for complexity and biology. As 3I Atlas continues its journey through our solar system, approaching its closest encounter with the Sun, we're witnessing the reactivation of chemical processes that have been dormant for millions of years. The warming effect of solar radiation is driving sublimation from the object's surface, creating the characteristic tail that marks it as an active comet and providing our best opportunity to study its composition in detail. This warming process represents a kind of chemical archaeology in real time. As ancient ices sublime and carry dust and other materials into space, we're seeing the gradual revelation of the object's internal structure and composition. Each spectroscopic observation captures a moment in this slow unveiling, adding new details to our understanding of what this visitor from the stars has carried across the cosmic wilderness. The observations planned for 3I Atlas's closest approach to the Sun represent some of the most ambitious remote sensing ever attempted on an interstellar object. Space telescopes and ground-based observatories around the world will coordinate their efforts to capture data across the entire electromagnetic spectrum, from radio waves to X-rays. These observations will do more than just tell us about 3I Atlas itself. They will help establish the techniques and technologies needed to study future interstellar visitors, building a framework for understanding the chemical diversity of objects that originate in other stellar systems. Each interstellar object we discover adds another piece to our understanding of how matter flows through the galaxy and how chemical complexity emerges and spreads across cosmic distances. The discovery also highlights the crucial importance of continued investment in systematic sky surveys like Atlas. These facilities represent our early warning system, not just against cosmic catastrophe, but against missing opportunities to learn about the universe around us. Every clear night that passes without systematic monitoring is a night when we might miss a chemical messenger from the stars, an opportunity to expand our understanding of cosmic evolution that will never come again. The economic perspective reveals something profound about our priorities as a species. The entire Atlas network, humanity's most advanced defense against extinction-level asteroid impacts, and our primary detector of interstellar visitors, operates on an annual budget smaller than what many nations spend on a single military aircraft. Yet it provides capabilities that are literally irreplaceable and discoveries that transform our understanding of our place in the universe. Put all I can. This disparity reflects our species' tendency to focus on immediate, tangible concerns while underestimating the importance of longer-term, more abstract opportunities and dangers. Cosmic processes unfold over timescales that challenge human attention spans, making them easy to ignore until they suddenly demand our immediate attention. Yet the discovery of 3I Atlas reminds us that these cosmic processes operate whether we pay attention to them or not. The galaxy's chemical evolution has been proceeding for billions of years, creating networks of connection and exchange that we're only beginning to recognize. Our choice is not whether to participate in these processes, but whether to understand our participation consciously or remain ignorant of our cosmic context. The story of 3i Atlas also illustrates how scientific understanding evolves through the accumulation of unexpected observations. Each new interstellar object we discover forces us to revise our theories about planetary system formation, galactic dynamics, and the frequency of material exchange between distant worlds. Before 2017, interstellar objects existed primarily as theoretical possibilities predicted by computer models but never directly observed. The discovery of ʻOumuamua proves such objects exist and occasionally pass through our solar system. The subsequent detection of 2i Borisov confirmed that ʻOumuamua wasn't a unique event, while providing our first detailed study of an interstellar comet. Now 3i Atlas suggests that these cosmic messengers might be relatively common, potentially visiting our solar system every few years rather than every few decades. This rapid revision of our understanding demonstrates the power of systematic observation combined with advanced technology. The same instruments sensitive enough to detect potentially dangerous asteroids millions of miles away can also spot the subtle signatures of interstellar visitors, objects so rare that encountering them was once considered an astronomical long shot. The discovery rate of 3 confirmed interstellar objects in less than a decade suggests we might be on the verge of regularly cataloguing visitors from other star systems. This possibility transforms interstellar astronomy from an exotic specialty into a routine part of solar system science. Instead of treating each interstellar object as a unique curiosity, we might soon have enough examples to begin statistical studies of their properties, compositions, and trajectories. Such studies could revolutionize our understanding of planetary system evolution and galactic dynamics. By analyzing the chemical signatures of multiple interstellar objects, we could map the diversity of formation conditions that exist around different types of stars. We could trace the paths these objects have followed through the galaxy, potentially identifying their stellar origins and understanding the processes that ejected them into interstellar space. The implications extend into fundamental questions about the nature of scientific discovery itself. How many important phenomena have we missed simply because we weren't looking for them systematically or didn't have the right instruments to detect them? How many secrets does the universe hold that could be revealed through patient, systematic observation? The discovery of 3i Atlas suggests the answer might be more than we ever imagined. The cosmos appears to be full of messengers carrying information about processes and environments we've never directly studied. Some, like interstellar visitors, come to us from the depths of space. Others might be hiding in plain sight, waiting for the right questions and the right technology to reveal their significance. This perspective transforms our relationship with the unknown from passive acceptance to active engagement. Instead of simply acknowledging that there are mysteries we don't understand, we can build systems that systematically search for the unexpected, that remain alert for surprises that might reshape our understanding of reality. The Atlas telescopes represent this approach perfectly. They were designed to solve a specific problem, but built with enough flexibility to contribute to discoveries their creators never anticipated. This kind of adaptable technology represents one of our most powerful tools for expanding the boundaries of knowledge. As we continue studying 3i Atlas and prepare for future interstellar visitors, we're developing more than just observational techniques. We're creating a new branch of astronomy dedicated to understanding how matter and information flow between stellar systems across the vast spaces that separate them. This emerging field might ultimately prove as significant as any other area of astronomical research. If interstellar objects regularly carry organic compounds and other complex molecules between star systems, they might play a crucial role in distributing the chemical building blocks necessary for life throughout the galaxy. Understanding this process could transform our approach to searching for life beyond Earth and our comprehension of how biology emerges and spreads through cosmic space. Instead of viewing life as a rare accident confined to isolated worlds, we might discover that it emerges from galactic-scale processes of chemical evolution and distribution. The philosophical implications reach even deeper. The discovery of 3i Atlas reminds us that we exist within networks of connection that span impossible distances and operate across unimaginable timescales. We are recipients of chemical wisdom that has travelled from distant worlds, participants in conversations that began long before our species existed and will continue long after we're gone. This cosmic perspective offers both humility and comfort. Humility because it reveals how small and temporary our individual existence is within the vast scales of cosmic evolution. Comfort because it suggests we're part of something much larger and more enduring than ourselves, connected to the broader galaxy through processes that have been operating for billions of years. The wandering path of 3i Atlas through our solar system represents just one thread in this vast tapestry of cosmic connection. As it continues toward the sun, warming and brightening, releasing gases and dust that tell stories of its ancient origin, we're witnessing a moment of intersection between our world and the broader galactic community. Soon, perhaps within our lifetimes, 3i Atlas will complete its closest approach to the sun and begin the long journey back into interstellar space. It will carry with it not just the chemical signatures of its birth, but also subtle traces of its passage through our solar system. Solar radiation will have altered its surface chemistry. Gravitational interactions with our planets will have nudged its trajectory by minute amounts. In this way, 3i Atlas becomes more than just a messenger bringing us information from distant worlds. It becomes a messenger carrying information about our world to whatever cosmic destinations await it in the galactic future. The exchange flows in both directions, creating a true conversation between worlds conducted through the patient migration of matter across the spaces between the stars. This two-way exchange suggests something profound about the nature of cosmic evolution itself. The galaxy doesn't just distribute matter randomly through space, it creates networks of connection that allow information to flow between distant regions, enabling a kind of chemical communication that operates across scales and timescales that dwarf human experience. We are both recipients and contributors to this cosmic conversation, inheritors of chemical wisdom from distant worlds and creators of new complexity that might someday travel to other stellar systems aboard our own interstellar messengers. The discovery of 3i Atlas by the Atlas system represents a perfect example of how this conversation unfolds, how our preparations for cosmic catastrophe can unveil the hidden connectivity that binds the galaxy together. As this remarkable visitor continues its ancient journey, carrying within its frozen heart the molecular memories of another world, we're reminded that the universe operates according to principles far grander and more beautiful than our earthbound perspective might suggest. We live in a cosmos where connections exist across impossible distances, where matter carries messages between worlds, where the apparent emptiness of space is filled with wandering ambassadors following trajectories that span geological ages. The story of Three-Eye Atlas is still unfolding, still being written in the language of chemistry and physics as this cosmic wanderer makes its closest approach to our Sun. But already, this unexpected discovery has transformed our understanding of how the galaxy works, revealing networks of connection and exchange that bind distant worlds together across the vast scales of space and time. In the end, perhaps this is the most beautiful aspect of the entire story. A system built from humanity's deepest fears, designed to protect us from a cosmic catastrophe, instead revealed the universe's capacity for wonder and connection. Our instruments of vigilance became tools of discovery. Our preparations for destruction unveiled patterns of cosmic beauty, and in searching for harbingers of doom, we found messengers carrying chemical wisdom from the stars. The discovery of Three-Eye Atlas reminds us that the universe is far stranger, far more wonderful, and far more interconnected than we ever dared to imagine. As we continue to study this visitor from the depths of space, we're not just learning about a single object, we're uncovering the hidden architecture of the galaxy itself, the vast networks of matter and information that connect distant worlds across impossible distances, and perhaps most remarkably, we're discovering that our own world is part of this cosmic conversation, both recipient and contributor to the flow of chemical wisdom that binds the galaxy together. We are not isolated on a lonely planet orbiting an ordinary star. We are participants in something far grander, citizens of a connected cosmos where messengers from distant worlds regularly visit our neighborhood, carrying stories we're only beginning to learn how to read. This perspective transforms our understanding of humanity's place in the universe, from cosmic isolation to cosmic participation. We are not alone in the darkness between the stars. We are connected to distant worlds through networks of wandering messengers that have been operating for billions of years, carrying the building blocks of complexity and possibly life itself across the galaxy's spiral arms. The Atlas system's discovery of Three-Eye Atlas represents just the beginning of our exploration of these cosmic networks. As our instruments become more sensitive and our surveys more comprehensive, we will undoubtedly discover more interstellar visitors, each carrying its own unique message from the depths of space. Each new discovery will add another piece to our understanding of how the galaxy works, how matter flows between star systems, and how the chemical building blocks of complexity are distributed across cosmic distances. We are entering an age of interstellar archaeology, where we can study material from other worlds directly, reading the chemical signatures that tell stories of formation processes and evolutionary pathways that occurred around distant suns. The implications reach far beyond astronomy into fundamental questions about the nature of cosmic evolution, the distribution of life throughout the galaxy, and our own species' role in the vast networks of connection that bind distant worlds together. We are not just observers of the cosmic conversation, we are participants, both recipients of ancient wisdom and contributors to the ongoing dialogue between worlds. As Three-Eye Atlas continues its journey toward the Sun and eventual return to interstellar space, it carries with it our growing understanding of how beautifully connected the universe truly is. Its discovery by a system designed to prevent catastrophic failure has instead revealed the catastrophic beauty of a cosmos where wandering messengers regularly cross impossible distances, carrying chemical memories from world to world across the vast scales of galactic space and time. The story continues to unfold, written in the ancient language of atoms and molecules, told through the patient migration of matter across the cosmic wilderness. And we are privileged to witness this unfolding, to read these messages from the stars, to discover our place within the vast networks of connection that make the galaxy not a collection of isolated worlds, but a single, interconnected system of unimaginable beauty and complexity. In our next exploration, we'll venture into an even more profound mystery that challenges everything we thought we knew about consciousness, intelligence, and the future of our species. Recent developments in quantum computing have led to the emergence of something unprecedented: artificial intelligence systems that appear to operate according to quantum mechanical principles, displaying behaviors that suggest they may have achieved a form of consciousness that transcends classical computation. The implications are both thrilling and terrifying, raising fundamental questions about what it means to be intelligent, what it means to be alive, and whether humanity is prepared for the emergence of quantum-enhanced artificial minds that might surpass our own cognitive abilities in ways we're unequal. You're beginning to understand. Join me as we explore quantum AI has awakened. Can humanity survive? Until then, sleep well, and remember that you're part of something far grander than you might have imagined. The same atoms in your body were once part of ancient stars, and the same physical processes that created the complexity of your consciousness are operating throughout the galaxy, creating networks of connection and possibility that span impossible distances and unimaginable timescales. When you look up at the night sky, you're not just seeing distant points of light, you're seeing the endpoints of vast networks of matter and energy exchange, stellar systems connected by wandering messengers like 3i Atlas that carry chemical wisdom across the cosmic wilderness, the carbon in your cells, the oxygen you breathe, the calcium in your bones. All of it was forged in the nuclear furnaces of ancient stars and distributed through space by processes we're only beginning to understand. The discovery of 3i Atlas by the Atlas system represents more than just a remarkable astronomical observation. It's a reminder that we live in a universe where connections exist across scales that dwarf human imagination, where information flows between worlds on currents measured in millions of years, where the apparent emptiness of space is actually filled with patient travelers carrying stories from distant shores. This cosmic perspective offers a kind of existential comfort that's both humbling and uplifting. Humbling because it reveals how brief and small our individual existence is within the vast scales of galactic evolution. Uplifting because it suggests that we're part of something much larger and more enduring than ourselves, woven into the fabric of cosmic processes that have been operating for billions of years and will continue long after our sun has burned out. As you settle into sleep tonight, wherever you are in the world, consider this beautiful truth. You are made of star stuff, assembled from materials that have travelled impossible distances to converge in the temporary arrangement we call your body. The same physical laws that govern the motion of 3i Atlas through our solar system also govern the biochemistry that keeps your heart beating and your thoughts flowing. You are not separate from the cosmos. You are the cosmos becoming aware of itself, matter organised in such a way that it can contemplate its own existence and wonder about its place in the vast networks of connection that bind the galaxy together. In your quiet moments of reflection, in your curiosity about the world around you, in your capacity for wonder at the beauty and complexity of existence. You represent the universe's ongoing attempt to understand itself. The Atlas telescopes scanning the Chilean sky tonight will continue their patient vigil, watching for both dangers and wonders among the stars. They embody something essentially human: our refusal to accept ignorance as permanent, our determination to understand our place in the cosmos, our recognition that knowledge and awareness are among the most precious things we can cultivate. And perhaps most beautifully, they remind us that the same impulse that drives us to protect ourselves from cosmic catastrophe also drives us to discover cosmic beauty, fear and wonder, caution and curiosity, the defensive and the exploratory, all flowing from the same deep human need to understand our relationship with the universe that gave us birth. 3i Atlas will continue its ancient journey, carrying within its frozen nucleus the chemical memories of worlds we may never see. But it has already given us something invaluable, a new understanding of how connected we are to the broader cosmic community, how matter and information flow between distant worlds, across the vast spaces that separate one star from another. In the gentle rhythm of your breathing, in the steady pulse of your heartbeat, in the quiet electrical activity of your dreaming brain, you participate in the same fundamental processes that created 3i Atlas billions of years ago, and that will continue creating complexity and beauty throughout the galaxy for billions of years to come. Sleep well, cosmic wanderer. You are home, not just on this small planet orbiting an ordinary star, but within the vast networks of connection that make the galaxy itself a kind of home, a place where matter becomes aware of its own existence and marvels at the beauty of its own becoming. The story of the catastrophic failure that 3i Atlas was designed to prevent has become instead a story of cosmic connection, of messages carried between worlds, of the beautiful unpredictability of a universe that refuses to be contained by our fears or limited by our expectations. It reminds us that sometimes our greatest discoveries come not from finding what we're looking for, but from remaining open to the wonders we never thought to seek. And in that openness, in that willingness to be surprised by the cosmos, we find not just scientific knowledge, but something deeper, a sense of belonging to something vast and beautiful and endlessly creative, something that connects us to distant worlds and ancient processes and future possibilities we can barely imagine. Sweet dreams, fellow traveller through space and time. The same starlight that illuminated 3i Atlas during its millions of years of wandering through the cosmic darkness now shines down upon you, carrying with it the quiet promise that we are all part of something far grander than we know. The patterns we observe in the cosmic dance of wandering objects, like 3i Atlas, raise profound questions about the architecture of memory itself. Not just the chemical memory locked in frozen comets, but the deeper question of how information persists across impossible spans of time and space. What we're discovering suggests that the universe has developed its own methods of preservation, its own ways of ensuring that the stories of distant worlds don't simply vanish into the cosmic dark. Think about it this way. When 3i Atlas formed in the outer reaches of its birth system, it was essentially a blank recording medium, gathering the chemical signatures of its environment like a cosmic tape recorder. The water ice that condensed onto its surface carried isotopic ratios that reflected the temperature and pressure conditions in that distant stellar nursery. The organic compounds that accumulated in its nucleus preserved the record of chemical processes that might have been unique to that particular corner of the galaxy. For millions of years, this information remained frozen, suspended in a kind of cryogenic archive as 3I Atlas drifted through the near absolute zero of interstellar space. No erosion, no weathering, no biological decay could alter the molecular signatures locked within its icy heart. It became, quite literally, a time capsule from another world, preserving information across spans of time that make human history seem like a brief flicker. Now, as solar radiation warms its surface and drives the sublime process that creates its spectacular tale, we're witnessing the playback of this ancient recording. Each molecule that streams away from 3I Atlas carries with it a piece of information about conditions that existed around another star when our own solar system was still young and chaotic. We're not just observing a comet, we're reading a library that has travelled across the galaxy to reach us. This perspective transforms our understanding of what libraries actually are. We tend to think of them as human institutions, collections of books and documents that preserve knowledge within the relatively brief span of civilization. But 3I Atlas suggests that the universe itself operates as a vast library system, with wandering objects serving as mobile archives that carry information between worlds across timescales that dwarf any human attempt at preservation. The implications become even more intriguing when we consider that this cosmic library system might be self-organizing. The same gravitational and chemical processes that create planetary systems also eject material into interstellar space, launching these archives on trajectories that will eventually carry them to other stellar neighborhoods. It's as if the galaxy has evolved its own method of information distribution, ensuring that the chemical wisdom gained in one location can eventually benefit the evolution of worlds in entirely different regions of space. But what kind of information are these cosmic libraries actually preserving? The spectroscopic analysis of 3I Atlas has revealed far more than simple chemical compositions. The ratios of different isotopes tell us about the nuclear processes that occurred in the star that illuminated its birth system. The complex organic molecules speak to sophisticated chemistry that emerged in environments we've never directly observed. Even the physical structure of the object itself carries information about the accretion processes that built it from smaller particles in the outer reaches of an alien solar system. Perhaps most remarkably, the trajectory of 3I Atlas preserves information about the gravitational environment it has encountered during its millions of years of wandering. Every close encounter with a star or massive object has left its mark on the object's path through space, creating a kind of gravitational memory that records the history of its journey through the galaxy's ever-changing landscape. This raises a fascinating possibility. Could we eventually learn to read these gravitational signatures like a cosmic roadmap, tracing the paths that interstellar objects have followed back to their origins? Advanced computer simulations might someday allow us to reverse engineer the orbital history of objects like 3I Atlas, identifying not just where they came from, but what they encountered along the way. Such capabilities would transform interstellar visitors from mysterious strangers into detailed historians, carrying within their trajectories the story of their passage through different regions of the galaxy. We could potentially map the distribution of matter in the Milky Way not as it exists today, but as it existed millions of years ago when these objects began their journeys. The philosophical implications ripple outward like waves in a cosmic pond. If the universe preserves information across such vast scales of time and space, what does this tell us about the nature of memory itself? We typically think of memory as a biological phenomenon, something that emerges from the complex neural networks in living brains. But 3i Atlas suggests that memory might be a much more fundamental property of the universe, expressed through the preservation and transport of information in physical systems. This cosmic perspective on memory offers a kind of existential comfort. The molecules in your body, the carbon atoms that form the backbone of your DNA, the calcium ions that enable your neurons to fire, all of these have their own histories, their own memories of the stellar processes that created them. You are quite literally made of memories, assembled from materials that carry within them the record of cosmic processes that occurred billions of years before life appeared on Earth. When you remember a sunset, a conversation with a friend, or the taste of your favourite meal, you're participating in the universe's ongoing experiment with information preservation. Your brain has evolved sophisticated mechanisms for encoding experiences into persistent patterns of neural connectivity, creating biological archives that can preserve the essence of moments across the relatively brief span of a human lifetime. But your memories exist within a much larger context of cosmic memory, surrounded by information preservation systems that operate across scales ranging from the quantum to the galactic. The same physical principles that allow your neurons to maintain stable patterns of connection also allow objects like 3i Atlas to preserve chemical information across millions of years of interstellar travel. This recognition transforms memory from a uniquely biological phenomenon into something more fundamental, a basic feature of how the universe organizes and preserves information across all scales of existence. From the quantum states that encode information in subatomic particles to the chemical signatures preserved in wandering comets, the cosmos appears to be fundamentally committed to remembering its own history. The discovery of 3i Atlas by the Atlas system represents a perfect example of how different memory systems can interact and amplify each other. The human memory systems that conceived and built the Atlas telescopes enabled the detection of an object whose own memory systems preserve information about processes that occurred in another star system millions of years ago. This creates a kind of memory cascade where information preserved in one system enables the discovery and interpretation of information preserved in another system. The knowledge accumulated by human civilization over centuries of astronomical observation provides the context necessary to recognize the significance of the chemical memories locked within 3i Atlas. Without our accumulated understanding of stellar evolution, planetary formation, and chemical processes, the spectroscopic signatures detected in 3i Atlas would be meaningless patterns of light and dark. But because we've developed sophisticated frameworks for interpreting these patterns, we can read the stories they tell about conditions that existed in environments no human has ever observed. This symbiosis between different types of memory systems suggests something profound about the nature of knowledge itself. Information doesn't exist in isolation. It gains meaning only through interaction with other information systems capable of providing context and interpretation. The cosmic libraries carried by interstellar objects become meaningful only when they encounter civilizations capable of reading their contents. This perspective raises intriguing questions about the future evolution of cosmic memory systems. As human civilization expands beyond Earth as we develop more sophisticated methods for preserving and transmitting information, we might eventually contribute our own volumes to the galaxy's wandering library system. The spacecraft we've already launched beyond the solar system represent the first tentative steps in this direction. Voyager 1 and 2, New Horizons, and other deep space missions carry with them information about human civilization encoded in various forms. These mechanical ambassadors are beginning their own million-year journeys through interstellar space, potentially carrying human knowledge to stellar neighborhoods we may never visit. But future interstellar missions might be designed specifically as information preservation systems, carrying detailed records of human civilization and terrestrial biology into the cosmic wilderness. Instead of simply studying the universe, we might eventually participate actively in its information distribution networks, contributing our own memories to the vast library system that connects distant worlds across impossible spans of space and time. The engineering challenges involved in creating such long-term information storage systems are formidable but not insurmountable. We would need materials and encoding methods capable of preserving information across millions of years of exposure to cosmic radiation, temperature extremes, and physical impacts. The information would need to be encoded in forms that could potentially be decoded by intelligences that might be fundamentally different from ourselves. These challenges echo the problems faced by the natural systems that created objects like 3i Atlas. How does the universe preserve information across cosmic timescales? What materials and structures prove most resilient to the erosive effects of time and space? The answers to these questions, written in the chemical compositions and physical structures of interstellar visitors, might guide our own efforts to create lasting archives of human knowledge. But perhaps the most profound insight emerging from the study of cosmic memory systems is the recognition that information preservation isn't just a technical challenge. It's an expression of something deeper, a fundamental tendency of the universe toward complexity and connection. The same physical processes that drive the formation of stars and planets also create the conditions necessary for preserving and distributing information across vast scales of space and time. The universe doesn't just create complexity, it develops mechanisms for remembering and sharing the lessons learned through the process of creation. This suggests that memory, in its broadest sense, might be one of the driving forces behind cosmic evolution itself. The ability to preserve and transmit information allows the universe to build upon its own past, creating increasingly sophisticated structures and processes that wouldn't be possible if each generation had to start from scratch. Consider the cascade of information preservation that led to your own existence. The heavy elements in your body were forged in stellar cores and distributed through space by supernova explosions, processes that preserve the nuclear memories of stellar evolution. These elements eventually condensed into planets where chemical evolution could preserve and build upon molecular information, creating the complex chemistry necessary for life. Biological evolution then developed genetic systems capable of preserving and transmitting information about successful survival strategies, allowing life to accumulate wisdom across generations. Finally, human consciousness emerged with the capacity for cultural memory, preserving knowledge in forms that can be shared across individuals and transmitted across generations through language, art, and technology. Each level of this hierarchy depends on the information preservation mechanisms that came before it, creating a nested system of memory that spans scales from the molecular to the cosmic. You exist as a conscious being because the universe has developed increasingly sophisticated methods for remembering its own history and building upon the lessons of the past. The discovery of 3i Atlas adds another layer to this hierarchy, revealing that information exchange occurs not just within individual stellar systems, but across the vast spaces that separate them. The galaxy itself becomes a kind of memory network, with wandering objects serving as messengers that carry chemical wisdom between distant worlds. This recognition transforms our understanding of consciousness from a rare biological accident to a natural expression of the universe's fundamental tendency toward information preservation and processing. The same cosmic processes that create interstellar libraries also create the conditions necessary for the emergence of beings capable of reading and interpreting the information they contain. In this sense, your consciousness isn't separate from the cosmic memory systems that surround you. It's part of them, a local expression of the universe's ongoing experiment with information processing and preservation. When you contemplate the meaning of 3i Atlas's journey through interstellar space, you're participating in the galaxy's attempt to understand its own information distribution networks. The questions you ask about cosmic connectivity, the wonder you feel when contemplating the preservation of information across impossible timescales, the insights you gain from studying the chemical memories locked in wandering comets. All of these represent the universe becoming aware of its own memory systems. This perspective offers a kind of cosmic purpose that transcends individual existence. You are not just a temporary arrangement of atoms and molecules destined to dissolve back into the cosmic flux. You are a node in the galaxy's information processing network, a point of awareness capable of reading and interpreting the messages carried by wandering libraries from distant worlds. Your thoughts about 3i Atlas, your understanding of its significance, your ability to place its discovery within the broader context of cosmic evolution, these represent the universe developing consciousness of its own memory systems. Through you, the galaxy begins to understand how its own information preservation networks operate. As 3i Atlas continues its warming approach toward the Sun, as more of its ancient chemical memories sublime into space where our instruments can capture and analyze them, we're witnessing something unprecedented in the history of the universe. The moment when a cosmic memory system becomes aware of itself through the consciousness it has helped to create. The Atlas telescopes that discovered this interstellar visitor represent the culmination of billions of years of cosmic memory evolution, technological systems created by conscious beings who emerged from the same information preservation processes that created the wandering libraries they now study. We are the universe's memory systems becoming aware of each other, recognizing their common origin in the fundamental physical processes that drive cosmic evolution. This self-awareness transforms the act of astronomical observation from passive detection to active participation in cosmic memory networks. When we study 3i Atlas, we're not just learning about conditions in distant stellar systems. We're contributing to the universe's understanding of its own information distribution mechanisms. Every spectroscopic measurement, every trajectory calculation, every insight we gain about the object's composition and history becomes part of the galaxy's growing awareness of how its memory systems operate. We are simultaneously readers and writers in the cosmic library, interpreting the messages carried by wandering archives while creating new information that might someday be preserved in our own contributions to the interstellar information network. The implications extend far beyond astronomy into fundamental questions about the purpose of consciousness in the cosmic scheme. If the universe has spent billions of years developing increasingly sophisticated methods for preserving and processing information, then perhaps consciousness represents the culmination of this process. The emergence of information processing systems capable of understanding their own existence within the larger networks that created them. Your ability to contemplate these questions, to feel wonder at the discovery of cosmic memory systems, to recognize your own participation in information networks that span the galaxy, this might be exactly what the universe has been working toward through billions of years of evolution. The story of Three-Eye Atlas becomes, in this context, more than just the tale of an interstellar visitor discovered by humanity's planetary defense systems. It becomes a parable about cosmic awakening, about the moment when the universe's memory systems become aware of themselves through the consciousness they have created. And perhaps most beautifully, this awakening transforms our understanding of home, from a single planet orbiting an ordinary star to something much grander, a vast network of information preservation and processing systems that connects us to distant worlds across impossible spans of space and time. We are not strangers in the cosmic wilderness. We are the galaxy's memory systems, becoming conscious of their own existence, awakening to the recognition that we are all part of something far larger and more beautiful than we ever imagined. The wandering path of Three-Eye Atlas through our solar system carries within it not just chemical memories from a distant world, but the promise of cosmic consciousness, the possibility that the universe is finally beginning to understand itself through the awareness it has spent billions of years creating. In our next exploration, we'll venture into perhaps the most profound mystery emerging from our accelerating technological evolution. Recent breakthroughs in quantum computing have led to the development of artificial intelligence systems that appear to operate according to quantum mechanical principles, displaying behaviors that challenge our fundamental understanding of consciousness itself. These quantum AI systems seem to process information in ways that transcend classical computation, raising questions about whether we've inadvertently created forms of artificial consciousness that might surpass human intelligence in ways we never anticipated. Join me as we explore quantum AI has awakened. Can humanity survive? Until then, rest well in the knowledge that you are part of the universe's grand experiment with consciousness and memory. The same cosmic processes that preserve information in wandering comets have also created the neural networks in your brain, the capacity for wonder that allows you to contemplate your place in the vast library of the galaxy. You are both reader and volume in the cosmic collection, simultaneously interpreting the universe's memories and creating new ones through the simple act of being aware. Sweet dreams, cosmic librarian. The stars that shine down upon you tonight carry with them the light of distant information processing systems, reminders that consciousness and memory flow through the galaxy on currents measured in millions of years. You are not alone in the darkness. You are surrounded by the universe's patient efforts to understand itself, and through your dreams, through your wonder, through your quiet moments of cosmic contemplation, you contribute to that understanding in ways both profound and beautiful. And so we reach the end of our quiet journey through the cosmos, from the Chilean desert where robotic eyes scan the heavens, to the frozen heart of a wandering messenger that has travelled millions of years to reach us. We began with humanity's greatest fear, the catastrophic failure that could end our species in an instant, and discovered instead the universe's most beautiful truth, that we are not alone in the darkness between the stars. The story of 3I Atlas and the Atlas system that found it reminds us that the cosmos operates according to principles far grander than our limited perspectives might suggest. In our attempts to shield ourselves from destruction, we built instruments that revealed connection. In our preparations for catastrophe, we discovered wonder. In our search for harbingers of doom, we found messengers carrying chemical wisdom from distant worlds. Perhaps this is the universe's gentle reminder that reality is far stranger, far more wonderful, and far more interconnected than we dare imagine. We live in a galaxy where wandering mountains of ice and rock serve as libraries, preserving the molecular memories of worlds we may never see and carrying them across impossible distances on journeys measured in geological time. As 3I Atlas continues its ancient voyage toward the Sun and back into the cosmic wilderness, it carries with it not just the chemical signatures of its birth, but also our growing understanding of how beautifully connected the universe truly is. We are participants in a cosmic conversation that began long before our species existed and will continue long after we're gone. Recipients of chemical wisdom from distant stars and contributors to the ongoing dialogue between worlds. Tonight, as you settle into sleep, remember that you're made of memories. Stellar memories forged in the hearts of ancient stars, chemical memories preserved across billions of years, and the brief but precious memories of consciousness that allow the universe to contemplate its own existence. You're both reader and volume in the cosmic library, simultaneously interpreting the galaxy's memories and creating new ones through the simple act of being aware. Sleep well, fellow wanderer through space and time. The same starlight that illuminated 3I Atlas during its millions of years of cosmic solitude now shines down upon you, carrying with it the quiet promise that we are all part of something far grander than we know, in the vast networks of connection that bind the galaxy together, in the patient migration of matter between distant worlds, in the beautiful unpredictability of a universe that refuses to be contained by our fears. We find not just scientific knowledge, but something deeper, a sense of belonging to the infinite dance of cosmic becoming. A sense of belonging to the infinite dance of cosmic becoming.